All right, today is the beginning where we really start diving into the details, the nitty gritty. Because if your details are off, you won't get this right. There's no way. And if you look at the board over there, the whiteboard, you have the rest basically of the year mapped out. Because by the time you come back, it will be the next year. It'll be 2026, which is kind of crazy. So you can see on the board, you got lessons, you got some homework days, you got whiteboard practice, you have a review. Notice your TOEO is due that day. So like your homework is done. You're not working on homework during that class time. All right? You are working on something else. So don't count on that, the 17th, as a day for you to get stuff done. It's a day that we are doing other things to help prepare you for your test. You notice there's no quick solve, which I know some of you rely on heavily. So that's gone. And then on Thursday and Friday, it says test. You're not taking a 2-day test. Okay, you are taking a 1-day test on either Thursday or Friday, and it really is just weather dependent. I will give you another day to review on Thursday, if we can. Otherwise, if the weather's not great and we push our lessons, then you would take it on Friday, or vice versa, whatever. So just realize it's kind of there, it's set up, so hopefully you are successful, okay? So today's lesson in focus is long division. Can you do long division? And can you use long division to determine if something is factors of each other or if they're not? And so that part's really easy. The long division is a little bit more complicated. And so actually the questions it asks you for number one, we're going to get rid of them. Just get rid of them. Okay? But we're going to use that whole page for some other stuff. Now, also, our lesson does not focus on solving. There's nothing solving in our lesson. But if I look over there, 3 of those lessons are all solving. And basically all of your lessons are methods to get to solving, and then we solve. So instead of waiting to the very end to show you some solving problems, I'm going to start showing you some solving so you get used to it. And then when we get to the solving, it's not as much for you to stomach. So we're going to start with long division. But to start with long division, you need to know a factor of your polynomial. What is a factor here that I know? What? X plus 1. Perfect. So my factor is x plus 1. And so what that means is I can actually divide this thing to find the other factor. Now, if it doesn't work out, we did something wrong. And I can say that 100% of the, with 100% certainty, because it gave me an answer right there. It gave me a solution. So if it doesn't work out, I know I did something wrong. We actually give you a question on the test with a graph and allow you to go ahead and solve it. And some people tell me that one of their solutions isn't the one staring right at them. That can't be the case. So please watch out for that. So I put my factor out here, x plus 1, and I put my function inside. Now this is kind of a unique problem to start with. So I'm going to show you a unique one, and then I'll show you 2 normal ones, and then we'll do one unique. One more, I should say. So how this works is I go, all right, x is all that matters. The plus 1 does not. The plus 1 is kind of like your younger sibling. Your parents are like, you got to bring them along, but you're just like, they're there. Whatever happens to them. If they're breathing, we're good. And that's kind of what we do with the plus 1 or the minus 2 or whatever is attached to your factor. You don't care about it at all. So another piece of advice that I will give you is use columns. I have an x cubed column. I have an x squared column, an x column, a constant column. So I am very detailed in how I write things today because it makes my life a lot easier. So when you're writing stuff, try not to fly all over the page. Try to keep it nice and neat. So x times what is x cubed? X squared. So I go to the x squared column and I put that there. So x squared times x is x cubed. And I drag that other sibling along and I go x squared times 1 is plus x squared. So I'm distributing this top part to my factor. and it gives me that. Now long division. Do I add them up together? No, what did you do in long division? You subtract. So I don't necessarily think subtract, I think flip signs. That's how I do it, I think it's easier. So I write this down and then I flip my sign. So negative and negative. So x cubed minus x cubed, 0. X squared minus x squared, 0. This is why I said it's weird. Normally that does not happen, okay? So I'm going to put 0 here. Now we drop this down and I get 3x. And this is the weird thing. So I think to myself, x times what is 3x? X times 3. So here's the deal. I have an x squared column, but now I'm jumping over an x column. So really what that means is I had 0x. So if I skip over this, I actually have to drop the next piece down, which is 3. So when, and you were correct, when you said I need to times this by 3, I go 3 times x, that's x squared. Notice I'm matching them. They're the same sign currently. That's good. Then I go 3 times 1, and I get plus 3. They're the same sign only for that little bit, because now when we subtract or we flip our signs, it goes like that. What do I get when I add these up? 0. That's what I want to see. That's how I know that I did this problem right. If my remainder is 0, that means I have found factors. So that means x plus 1. Whoa, I'm going to redo that. That just got messy. X plus 1 times x squared plus 3 is equal to this cubic. So I have factored form and I have standard form. We found factored form because factored form makes the problem very easy to solve. And a couple of you are like, that is not easy to solve. That does not look very nice at all. But bear with me for a moment. I told you we're going to kind of ignore the problems on the page, and we are, because I want you to see a solving piece. If I'm solving this, I'm not going to solve standard form. Yup, I would have to do everything that's there to get to right where I am. So instead, I'm going to solve the factored form. So 0 equals x plus 1 and x squared plus 3. What's my solution to that? Yeah, it's just x equals negative 1. Put a little box on it. It's done. That's not too bad. I mean, that was actually really easy. If I look at this next piece, it looks bad, but it is also pretty easy. So I go like this. X squared plus 3 equals 0. So I minus 3 to the other side. Easy. And now what? We take the square root. It is imaginary. And that's actually really completely fine. It's actually good. It matches up with our problem. So I'm going to add that plus or minus right off the bat. And because we already said it's imaginary, I'm going to say x equals plus or minus I square roots of 3. So I now have 1, 2, 3 solutions. And I counted that twice because of the plus or minus. I also say that's good because if you look at your graph right here, I cross the x-axis once. So if I only cross it once, I can only have one real solution. Does that make sense? I have one real, 2 imaginaries. So that's good. So what I need you to realize what I just kind of highlighted in green, this little boxed out part, we will get to this. And I will keep showing you these over and over again. But you don't have to worry about this. Today, our focus is on this. Can we do that? All right? So, if you're good on this page, flip it over. And now we dive into it. For comma 0. That's what an x-intercept of 4 would be. Now it's asking us a question. It's not stating that as a fact. It's saying, is that an x-intercept? Okay, so we're going to find that out. But to do that, I'm going to do some log division. And I'll also say that I need the factor. I don't need the solution. So what's the factor of 4 comma 0? X minus 4. So remember, factors are the flip of it. Just like the flip of a factor is the 0. So I get x minus 4. And on the inside, I have this cubic. And I don't know if I said this class, but I'll throw it out there. You don't have any notes, I won't help you, okay? This is a unit full of details. You need to have them down. So, take good notes. Now, let's talk about this. X times what is x cubed? X squared. So I go to my column and I go x squared. Oh. And then I distribute to both x and to the negative 4. So I got x cubed. And then I get minus 4x squared. Draw my line. What else do I do? Subtract. Okay? So I flip those signs. So now I come and I subtract. And this actually becomes a plus because it's minus minus. So that's gone. And then I end up with 6x squared. This one is what I would say is like a normal long division problem. Okay? So after I do that, I go ahead and I drop down negative 5x. And I stop there. This is the normal chain of events. So I would say this is more tedious than it is difficult. But our next question. I need x times some number up here to be 6x squared. What number is that going to be? 6x. Also notice, look how the powers are going. I went square to x. My next one's going to be a constant. It follows that pattern. If you have an x squared and then you multiply by an x squared in the next line, you did something wrong. Okay? It should go down in order. So, I multiply, I get 6x squared. And then I multiply again, and I get negative 24x. And that's coming from the 6x times the negative 4. What do? Subtract. So I flip my signs. Cancels out. If this doesn't cancel out, you did something wrong. So there's lots of little hints to tell you what's going on. So that cancels out, and then this becomes 19x. So I drop the 16 down. What am I going to multiply by to get 19x? Just 19. Yeah, just 19. So x times positive 19. This is where I'm looking. These two things, they multiply to make that. So I get 19x. Any fast mental mathers out there? What's negative 4 times 19? 70. Oh, go for it. 70 what? Very nice. So that should be a minus sign, my mistake. But actually it becomes a plus sign because then we change our signs. So I flip, and I combine them up together. 19x is gone. What's that add up to? 92, very nice. Very nice and very not nice. This needs to be 0 if we have a factor. So how I would write this, if I needed to write those two things out together, I would write it like this. Plus 92 divided by whatever I was dividing by. Minus 4. But that's not the question that we're being asked today. What we're being asked is, does the function f of x have an x-intercept of 4? No, it does not, because my remainder was not 0. So no, And my reasoning is just going to be r equals 92, but needs to be 0. So if your remainder is 0, you have found another factor. Questions? What goes on the outside here? X minus 3 is perfect. My function goes on the inside there. What do I multiply by first? I'm going to combine both your answers. 2x cubed. So this right here multiplies to something up here. So x times 2x cubed is equal to 2x to the 4th. I don't care about the minus 3 at all. So you'll notice even that I don't even ask you 3 times what is something, because I don't care about it. It's just out there and it just works itself out. So 2x cubed times x is 2x to the 4th. And then I multiply and I get negative 6x cubed. What do? Subtract. So draw my line, I flip my signs, minus, plus, and so this cancels out. Good, it should, it needs to. And then I add up and I get 17x cubed. Now what? No. I gotta do something first. Yeah, we gotta bring this down. So I'm gonna minus 5x squared. Now I'm gonna go ahead and say, okay, now x times what is 17x cubed? That would be that 17x squared. So, little piece of advice. This number is positive, so I'm matching that sign. If this was negative, then I would change this and make it negative 17x squared. Okay? So you can have minus signs up there. We just don't in these examples. But so I multiply, I get 17x cubed. And then I go 17x squared minus 3, which is what? Come on, fast mathers. 51x squared. Very nice. What do we do now? Subtract. Draw my line, I flip my signs, and subtracting cancels, and this gives me 46x squared. What do I do now? Bring down the 98x. Reminders. Or not reminders, what do I do next? You guys are doing really good, so I'm gonna keep letting you go. 46x, good. Again, notice how it goes cube, square, and then just an x. So plus 46x. I multiply it, I distribute really. Fast mathers, what do you get? Nice. Aiden? That's right. We subtract. And very nicely, this cancels out. What am I left with here? Oh, I should keep that 6 in there. Yeah, negative 40x. Positive 40x, sorry. Now what do we do? Yep, drop that all the way down. $40 is good, so I put plus 40. So I get 40 times x, 40x. I get 40 times negative 3, negative 120. That's actually exactly what you want to see because, Aiden, you subtract, which changes my signs to cancel them out. And I get 0. So does this have a factor or an x-intercept of x minus 3 or 3? Yes, it does. And all I would say is that r equals 0. That's my reasoning. The remainder is 0. That's all you got to say. That's it. Okay? Questions? Yeah. Right here? Yeah. I snuck that 6 in. I wrote it down as negative 4x squared, and then I saw that I missed it. It should be negative 46x squared. Okay? That's a really good question. Other questions? Yep. You're talking here? Because obviously here, that's what was happening, right? It is not always going to be that case. Now, it happens that way in this problem because we have a negative back here. But remember, like, we do have factors of x plus 2. So, like, if I have a factor of x plus 2 and I go this times, you know, let's just say 40, that gives me 40x plus 80. When I subtract, that actually makes that a minus. So it's not always the case, it's just something that happened in this one, and I believe the other one. So it's a good question, good observation. Any other ones? Eli, what's your question?
I did not see.
Aiden, what's your question?
He doesn't know how you got the 6x plus 3. How you get these numbers? The first one.
On the first one? To this problem?
Oh, the first step.
This one?
Yeah.
You said 6x cubed? The 6x cubed? Okay. All right. So I get it from this. Because when you multiply, you're really distributing. So I multiply to this x. So I get 2x cubed times x, which is negative, or is the 2x to the 4th. But you also go to that. So 2x cubed times negative 3 is that negative 6x cubed. Which then when we flip the signs, it becomes positive. You're doing that for every single one. When I do 17, that's where that 51 came from. When I do the 46, that's where the negative 138 comes from. Jace.
Sounds kind of stupid. So basically, first part you're multiply, and then you also add or subtract. For like, there's like 2 parts to it. For like each time you go down.
Yep.
Okay.
Why are you doing this time? Like, why?
Answer me this. When I do long division here, I go, okay, I'm going into 10, right? So 3 times 3 is 9. Do I add them up then? No, I subtract.
So it's just like.
It's part of the rule, but really what it comes down to is I'm taking groups out. That's what division is. I'm looking for groups. How many groups of something can I take out? But that's the key word is the take out. So that's why we're subtracting. Is that kind of? Yeah? All right. That's a really good question. Any other questions? All right, we got one last example here. All right, a little bit different. because of what? What's different about this one? It's 3x. It's not just x. So today we look at long division. Tomorrow we look at, not tomorrow. Next Monday we look at synthetic division. Now, they're very similar, except for synthetic division we don't use if we have a number attached to the x. So then you have to use long division. So we're going to see how this works. So I draw this out. Where's the 3x plus 1 go? Outside or inside? Outside. My function goes inside. What's the first thing I multiply by? 4? X squared. I like x squared. I need more, or do I not need more? Is that good? X squared times 3x gives me 3x cubed, so it's good. It's perfect. Very nice. So I start here. So I got 3x squared. So multiplied there, multiplied there. I'm going to get rid of those arrows. So when I multiply to the 1, I get plus x squared. This one's kind of unique, just like the first one that we did, all the way back at the beginning of the lesson. So Aiden, what's the next step? Subtract. So cancels, and this actually cancels too, so I'm left with 0. So I drop this down, this negative 12x, but I'm actually going to drop the next one down too. Because, tell me this, 3x times what is negative 12x? Negative 4x. Or sorry, just negative 4. So that means I'm going to my constant column. So if I put negative 4 right there, what happened right here? I skipped over the x. Okay? And that's fine. But if I do that, if I skip over, if I jump a degree, then I have to drop the next one down. So I go negative 4 times 3x, and I get negative 12x. I go negative 4 times 1, I get negative 4. And Aiden, we subtract, which means we add, but that's good because it cancels everything out and we get 0. Yes?
Why did you leave the, what was in parentheses, 3x plus 1 when it said there was an intercept of 3, like with 2, and we put in parentheses as 3, comma 0, and then flipped it?
Yes. Great question. And it's the detail on it. What's this say? Is 3x plus 1 a factor? Whereas if I look at these back ones, it says x-intercept. Factors go on the outside of long division. X-intercepts do not. Okay? So, that's a really good question. But so, we're going to do something kind of unique here. Look at this. It says solve 0 equals 3x cubed plus x squared minus 12x minus 4. Whoa, whoa, whoa. They're the same thing. So instead of 0 equals this, get rid of that and put 0 equals our factored form. Our factored form is 3x plus 1 times x squared minus 4. Now there's a couple things about this chapter. So one of the things is we ask you to do long division. You've seen that today. Now you got to practice it. We ask you to do synthetic division, synthetic substitution. You'll see that next week. Yeah, you practice it. We also ask you to factor a lot of things. So sometimes you start that process by using this method or another one. Sometimes you can just factor. If I ask you to factor this completely, is that factored completely? What can I factor more? What's the x squared minus 4 factor to? Oh my gosh. The difference of perfect squares. You're the first one all day to get that. You don't know how happy that makes me. Because you know what? Chapter 5, this shows up all the time. All the time. You're going to look at a problem, you're going to be like, I factored in nickels, here's the test, I'm good. and you're gonna look at it, and I'm gonna go -1, and you're gonna go, and I'm gonna go, it's not factored completely. So, this does factor to x plus 2 times x minus 2. And now if we solve that, one of my solutions is -2. One of my solutions is +2. This one you gotta do just a little bit of work. You go 3x plus 1 equals 0. I -1 minus 1. And I would divide. And so I get x equals -1/3. Now I went through that pretty quick because our focus again is on the long division today. I just want to expose you to this other stuff. Okay? Question?